Alright, so to begin out rational expressions, we have to talk about simplifying fractions. Rational expressions are fractions that just have x's in them and math expressions in them, but they operate like fractions. So remember, to simplify a fraction, you're really canceling out versions of 1. What do I mean by that? Well, if you break something up into its factors, for example, a 2 is just a 2 times a 1, and a 4, you could either say 4 times 1 or you could say 2 times 2, and I'm going to say 2 times 2 because anything divided by itself is equal to 1. So here's a version of 1 right here. Multiplying by 1 doesn't change the answer, so this is just making it look bigger than it needs to be. Really, 2 divided by 2 is equal to 1. So this is saying 1 times 1/2. Well, hey, the answer is really just, in simplest form, 1/2. Okay. Same idea over here with the 2 times 2 instead of the 4, and 2 times 3 instead of the 6. If we break those out into their factors, we can figure, 2 divided by 2, that's equivalent to 1. Multiplying by 1 doesn't change the answer. So in simplest form, the answer should just be 2/3 here. Okay. Something like 21. Let's see, that's got to be 7 times 3. And what's 54? 9 times 6, right? Okay, well, that wasn't small enough to find any version of 1. But 9 and 6 are not prime numbers. They can split up again. So what if I thought of, I could split both of them up, but what if I just split up that 9 into, well, I already wrote 9, sorry. Let's split up the 6 into 2 times 3. How about that? Could have split up either one of them. So by doing that, I found that I have 3 divided by 3, which is equivalent to 1. So I can cross that out because multiplying by 1 doesn't change the answer. The simplest version of the answer is 7 divided by, here I have to put the 9 times 2 back together, so 18. Alright, so what if it's a rational expression, not a good old-fashioned elementary school fraction? Well, factoring just becomes a little more complicated. Factoring, remember, look first for a greatest common factor, and then try some of your strategies like difference of squares, if there's 2 terms. Oops. Or maybe you can just unfoil if a equals 1. Or if a is not a 1, then you might have to do AC method. Okay. So here in this first one, this 4x plus 12, I can make that a multiplication problem. I can take out the 4, right? I can undistribute the 4, which would leave us with x plus 12 divided by that 4 would be 3. I've undistributed the 4. So now I have this 8 on the bottom. When I see that I already have a factor of 4 on the top, then it probably becomes helpful to think of the 8 as 4 times 2, right? So now I can say, here's a factor divided by itself. 4 divided by 4 is equal to 1, so I don't need it. I'll just have x plus 3 divided by 2. That is the simplest form of my answer. I encourage you to leave these binomial factors in parentheses to keep you from doing too much canceling out. I'll show you what I mean in a better one than this. Okay, I'm going to skip this one. This one's very similar to what we had, and I'm going to move on to this row. So this, at first glance, also looks very similar, but I want to do it for a different reason. So this top part, is there a greatest common factor? Always ask yourself that question. Let's see. 2 and 6 can both divide by 2. If I have x to the third here and x squared there, I can take out 2 x's from both. right? So 2x squared. That would leave an extra x, the plus sign, and 6, if I remove the 2, leaves me a 3. And since I brought both x's outside, x squared's outside. 3x, that's just 3x, or 3 times x if you want. But no breaking down of that. So now the hard part. Is there anything divided by itself? Not exactly the same looking, but yes it is. With these monomials, this part that the greatest common factor here, you can do the number divided by the number, but 3 and 2 are different numbers, so that won't work. But you can treat the x's as well. You could have placed a multiply dot between the 2 and the x squared, meaning that the 2 is a separate factor from the x squared. You can get even sneakier. You can think of that 2x squared as an x times an x. That's even more detail about how to think about this. And so all of these are separate factors, and all of these are separate factors, and then that's a separate factor. So any factor divided by itself can be crossed out. So this pair of x's, for example, that would be an example of a pair of factors dividing to make 1 that I would want to cross out. So I still have to keep 2x and x plus 3, but on the denominator I just have a 3 now. I've lost one of my x's from the top and my only x from the bottom. Okay, what if it's not something with a greatest common factor? At first glance, we might try to take the x out of this numerator, but there's no x behind the 4. So no GCF. But this is a perfect square. So this is that differences of squares thing. X squared minus 4 would just be x plus 2 times x minus 2. And then down here, x is, there's an a of 1. So I can just unfoil this. What are the two numbers that multiply to negative 8? That add to positive 2. X times x makes our x squared. Let's see, things that multiply to 8 and add to 2. Negative 8. So a 4 and a 2. Since the 2 in the middle is positive, then that means my bigger number will be positive, and my smaller number of the pair will be negative. So this should be plus 4 and subtract 2. So now I'm looking at my 4 binomials. I can't look at the individual pieces in the binomial. It's all of the parentheses or none of the parentheses get canceled out. So right here I have 2 identical x minus 2's. X minus 2 divided by x minus 2 equals to 1. So it is not changing the answer, it's just changing how the fraction looks. These guys are different. X plus 2 and x plus 4 are not exactly the same. So our answer is going to be x plus 2 divided by x plus 4. Okay. Keep them in parentheses, like I said, so you don't suddenly try to cancel off the x's because the x's look the same. They are trapped in the parentheses as a binomial. They are not monomials. So you either have to keep both pieces or get rid of both pieces. So in this case, we keep them. Up here where they were identical, we got rid of them. All right. So ask questions if you need to, and give it a go.